In this video, we're going to solve problems using the percentage formula. Before we start working on some examples, we have to talk about what is the percentage formula. I like to think of it as part over whole equals percent. And this percent is in decimal form. Our textbook uses slightly different words, but really it's the same formula. So they say for part, it's portion. And instead of whole, base. And then instead of using the word percent, it's the word rate. And then we can abbreviate this to P over B equals R. And again, this is in decimal form. So this is the equation if you wanted to solve for rate or percentage. But we could solve for the portion or the base. If we wanted to solve for the portion, that would be base times rate. Or you could say rate times base, either way. So this is a second formula, but really, if you know this formula here and you're comfortable rearranging equations, you can multiply both sides by b. The b's cancel here, and we end up with p equals r times b, which is our second equation. And then we could also solve for the base, which would be portion over rate. And again, it's really not a third equation, it's just this first original equation rewritten. So let me rewrite this equation. If we wanted to solve for rate, it's portion over base. These are the three equations that we're going to be working with in this section. So when you're dealing with problems involving the percentage formula, what I would recommend doing is writing down R for rate, P for portion, and then B for base. And what you want to do is fill in these numbers. You're going to be asked to solve for one of these numbers, so in the problem you should be given the other two. Rate is generally pretty easy to figure out because it is the percentage and it often will have the percentage sign with it. So the rate is 10%. In decimal form, that would be 0.1. I write that because when you're actually doing the calculations, you want to make sure you're using the decimal form of the percentage. Portion is the part, and then base is the whole. So we're taking 10% of 250. So that would be our whole or our base. And we're being asked what number is this? So this is what we don't know. We are solving for portion, which means we are going to use the equation portion equals rate times base. And now that we're doing the calculation, we want to make sure our rate is the one in decimal form, 0.1 times 250 gives us 25. So our portion is 25. So first thing, write down your three variables, rate, portion, base. The rate is 10% again. 10% of what number? So 10% of a base is 8. And this one, we are solving for the base. When we're solving for the base, we use the equation base equals portion over rate. The portion is 8. The rate is 10%, but again, we need to do the math with the decimal form. So we would use 0.1 instead of 10%. 8 divided by 0.1 is 80. All right, next one, 9 is what percent of 90? We are being asked for our percentage, so we don't know our rate. 9 is the portion, and then 90 is the base. This is the part, this is the whole. And generally the part is smaller than the whole, but that's not always the case. So take, for example, an exam grade. Perhaps there was 100 points possible on an exam, so that would be the whole or the base, but you got a 105 because maybe there was a bonus question, or maybe there was an extra assignment that you passed in with the exam to get some bonus points. So it's not always the case that the base is a larger number. Usually it is, but it's not always the case. Alright, so if we're solving for the rate, our equation is portion over base, which would be 9 over 90. And that works out to 0.1. However, you don't want to report this as your answer because this is the rate or percentage in decimal form. And when you're reporting your answers with percentages, you want to actually report it in percentage form. So it would be 10%. Let's try a couple more examples. A department store sold 70%, so there is our rate of its pairs of shoes in stock. The store sold 329 pairs of shoes. If they sold that many, then how many did they have in stock? So we have rate, portion, base. Our rate is 70%, or 0.7 in decimal form. Our portion, that's the part, that's the amount they sold, which was 329. And then we don't know how many shoes they had in stock, so that's our base. We are solving for base, so our formula would be base is portion over rate. The portion is 329. The rate is 70%, but we want to use decimal form when we're doing the calculations, so 0.7. 329 divided by 0.7 gives us 470. So the store must have had 470 pairs of shoes. Final example. In a welding shop, 104,000 welds are made. 97% of the welds are acceptable. Then we want to know how many are acceptable. Our rate is 97%, so almost all of the welds are good. And this is 0.97 in decimal form. We want to know how many of the total welds are acceptable, so we're looking for the portion. And the total number of welds is 104,000. We're looking for P, so our formula would be portion equals rate over base. Rate is 0.97, and base is 104,000. And when you multiply those together, you get 100,000, and 80 of the welds are good. Now, like I said in the beginning, I like to think of problems like this as part over whole equals percent. So if I was solving this problem, I would set up this, and I would say, okay, I don't know the number of welds that are acceptable, so I'm going to put an X there. My total number of welds, that's the whole, 104,000. And then my percent is 97%, or 0.97. And from there, I would multiply both sides by 104,000. Those would cancel. I'd be left with my X equals 0.97 times 104,000, and we end up in the same place. So if it makes more sense to you to use these words rather than these letters here, you'll end up at the same place.